Alright, quick stats video. This is problem number 4. It says an automobile company wants to learn about customer satisfaction among the owners of 5 specific car models. Large sale volumes have been recorded for the 3 of the models, but the other 2 were recently introduced. The models D and E are new, and we know that because their volumes are smaller. The number of cars sold in the last 6 months is shown here. The company can obtain a list of all individuals who purchase new cars for the 5 models, and they want to sample 2,000 owners. For simple random samples of 2,000 car owners, what's the expected number of owners of Model E and the standard deviation of Model E? Okay, so expected value is N times P, so the number I buy times the probability. By the way, this is a binomial situation because remember the 4 conditions: fixed, N, P is constant, success or failure, independent. So N in this case is we're picking 2,000 cars. And what is P? That's the probability of car E. Well, the probability of drawing E is 2323 divided by the total, 297, 354. So P is 2323 divided by the total, 297, 354. 297, 354. So when we do that, we get 0.00781. So expected value of car D, our 2,000 is N, times 0.00781, which equals 15.624 cars. So on average, we should expect to get about 15 cars from group E. Now, what about the standard deviation of X? Well, if you go to your formula sheet, which is at the front of this packet, you'll see right here that standard deviation of binomial is what I'm highlighting here, is N square root of NP times 1 minus P. So this is square root of N times P times 1 minus P, which is equal to square root of N 2,000 times P 0.00781 times 1 minus 0.00781. And what do you get for standard deviation? Well, you do the math, 0.00781 times 1 minus 0.00781, all times 2,000. Raise it to the point we're taking the square root of that, and we get 3.937 is the standard deviation. So we got our expected value here, number of cars times the probability, and then we used our formula sheet which said N times P times 1 minus P, plug this into our calculator, and we got this many cars as a standard deviation. So that's part A. Let's take a look at part B now. Part B says, 4B, here we go. When selecting a simple random sample of 2,000 no car owners, how likely is it that fewer than 12 owners of Model E would be included in the sample? Justify your answer. Let's take a look at 4B here. So we want to know, right, what is the probability? We're taking 2,000 car owners that fewer than 12 will be in this sample. So we want to know the probability that X is less than 12. Well, again, we talked about how this is binomial, so I can use binomial CDF from 0 to 12. The expected value they're going to want is 15.624, and the standard deviation is 3.937. Binomial CDF is what we're using here. By the way, probability that X is less than 12 is probability of 11 plus the probability of 10 plus the probability of 9, but like literally who wants to add this up every time? It's much easier to do this way. So distributions, binomial CDF, how many trials? 2,000. P-value is 00781. Although you don't really need this. I'm sorry, I was thinking normal CDF here. You do not need this. You just need lower bound, upper bound, and the probability. 0.00781. And the X value is 12. And here we have 0.21842. .21. Alright folks, I want to indicate a mistake that was made here. Please notice the mistake I made here. This should have been 11. Why 11? Because it's just less than 12, which means you want to stop at 11. You do not want to go to 12. Folks, this was a big mistake I just made here, and I want to be very clear about it. We said what is the probability that X is less than 12, not less than or equal to. So we just do binomial CDF 0 to 11, and we'll get 0.1459. So there's about a 15% chance of having between of having less than 12 folks. All right, and let's go on to part C. The company is concerned that a simple random sample of 2,000 owners would include fewer than 12 owners. Describe a sampling method that will ensure at least 12 owners for all the car methods. So here we want to do in 4C, we want a stratified sample, then select randomly within each strata, and that stratas are the car models. This will guarantee a certain number of cars per model. Right, folks? So again, if you take a stratified sample, then you select randomly within each strata, within each car model, then you're guaranteed a certain number of cars per model, and then the company can be confident that they'll get at least 12 cars for models D and E. Hope this video was helpful, and I will see you all tomorrow.